Okay, so this is just the re-recording of the last week discussion. So last week when we are doing the online session, so we are facing with some technical issues. So the recording was not properly taken. So to rectify this thing, I am again re-recording the whole session. The only problem is that here there is no option to interact with you. So this is just the problem solving session. So I will discuss each of this problem and I will try to discuss the steps to solve the problems. So okay, so let's start. Okay, so the first problem that we have discussed that day was related to this smoothing thing. So given a corpus, so in the right side you can see there is a corpus given. Now the question, now the thing is that, so they are asking two different questions. So what is the relation between the continuation probability of and what is the relation between continuation probabilities of and in? Okay, so and they assume two things. So you should not you can just ignore these lower cases and punctuations. So this is the assumption, and we will see why they made such assumption later. So before going to the problem, so before going to the problem solving stage, so if you recap, so if we can recap what is this continuation probability. So let me just write it here for you. So P continuation, so writing is P continuation of a word W. So if you remember the formula correctly, so basically this is the probability, this is the ratio between two things. One is the total number of, I'm not going with formal formula for this pre-continuation, but I'm just writing what the formula truly means. So basically the pre-continuation of W means the total number of unique bigram. For this case we are only considering the bigram, total unique bigram in our corpus, in the corpus, and in the upper part, so the bigrams, the unique bigram which W ends with. Okay, so basically this is the ratio of two things. So total number of unique bigram in the corpus and the bigrams which has the W is constituent of this bigram and W completes the bigram. Okay, so this is the thing. So now let's see in the question how to solve this question. So first find what are the different bigrams where and present. Okay, so let's see. So in the in this paragraph you will see, so there are multiple places where and present in a bigram, not just present in the bigram but as a ending bigram. Okay, so the and like this and completes the bigram. It's not the first word of the bigram but the last word of the bigram. Okay, so if you see, so there are 5 places where and ends with the bigram ends with and. Now among those 5, this first and so this is common. So there are 4 unique bigrams. So it is 4 by B. Now you can ask why we are writing B. So basically we are not interested in finding the total number of unique bigrams because that will be same for and in. So B is kind of constant here. So we are just finding the unique bigram where and present. Okay, so this is 4 by B. Okay. Similarly, if you find for and for in, so for in also there are 4 places where you can find the in completes the bigram, and there are 4 distinct bigram and no repeating ones. So here again, so the continuation probability of in is 4 by B. So what is the relation? Then both are 4 by B. So the correct answer is C. So the continuation probability of and continuation probability of in both are equal. Okay, now let's see. So if you go to the previous slide here, so why they are saying to ignore the punctuation and lowercase, you can see. So if you are not ignoring the punctuation, then abstract comma and, okay, so this abstract comma and will not be a diagram, it will be a triagram, because then this comma will be another word in this whole diagram thing. So if you ignore this comma, then it will be just abstract and end. So for the sake of simplicity, they are assuming like they are, we can ignore this punctuation and lowercase. Okay, so there's the thing. So if this comma is there and in the question there is no assumption made to ignore the punctuation, then this is not a diagram, it will be a triagram. Okay. Similarly, if you in the question, if it says that like you cannot ignore the lowercase, like basically then this here, then this capital here and this small here would be the same thing. Yeah, so it would be the different thing. So this is the thing. So in this question, for simplicity purpose, they are saying that you can ignore the lowercase and punctuation. Okay. So all this, like basically they are saying that all these things are in lowercase and there is no punctuation. This is the assumption to solve this question. So basically the concept is pretty clear. The concept is that you need to find the distinct distinct diagram that end with this word that is given. So this, for our case it is and in, and you just need to compare those two probabilities. I hope it is pretty clear. I don't need to like explain it again and again. So you just need to calculate the continuation probability of and into continuation probability in, and then you will get the comparison between those two. And the continuation probability formula is this thing. So the total number of unique diagrams in the corpus, and the unique diagrams which W ends with. So the unique diagrams which ends with W is the upper part. So the numerator, and the denominator is the total number of distinct diagrams in the inner corpus. Okay. So in this example, and present 5 times in your corpus in different diagrams, but among those 5, so this first and repeats. So there are 4 distinct diagrams. So the continuation probability is 4 by B. Similarly, if you go with in, so this in also present 4 times in your corpus, and you are dividing by B. So B is the total number of unique diagrams. So you don't need to find the total number of unique diagrams, because this thing is same for and in both the things. So we like, it's not important to find the B, so we just compare the 4 by B and 4 by B. So both are same, so the answer is okay. So I hope it's clear. So let's move to the next question. Okay, so in this question, what they are saying is that like you are reading an article on sentiment analysis, you encounter the words on the right. Okay, so you encounter the words on the right. Right. So you can see this. There are multiple words, and their frequencies are given. Now, what they are asking is that like, can you estimate the MLE and GT of architecture? Okay, so the word architecture. So they are asking. So before going to the question, so we need to understand what is MLE. Yes, MLE is just to recap. MLE is a maximum likelihood estimate. Okay. So what is that? Like what is the maximum likelihood estimate of a word? So basically total number of unique word in your corpus by the number of occurrence of this word. So basically if you write it here, so MLE, maximum likelihood estimate of a word, is basically so you can write it like sorry. Okay, so so it's basically total number of unique words. So total unique words in the corpus by count of W in the corpus. So basically this is the maximum likelihood estimate of the word W. So if you go by with this formula, so let's see what is the MLE of architecture. So now let's check. So how many times architecture occur in your corpus? You cannot so there are sentiment, etc., all these things, but you cannot find architecture. So the count of architecture is 0. Okay. Now, so basically the numerator is 0. Now what is the denominator? So total number of unique words. Total number of unique. So total number of, actually it's not the total number of unique words. Actually I have written this now. So total. So let's write it clearly. It's basically total words in the corpus. The words count. Basically it's the count. The total words count. I hope you guessed that thing. Okay. Now let's see. So how many different total number of words in the corpus? So there are 3 words, each occur 5 times. So so it is 15. So then 2 words occur thrice. So it is 6, and this 4 word occurs once, which is total count is then 4. So it will be 15 plus 6 plus 4. So it is 0 by 20. Okay. So the MLE of architecture. So here the W is architecture. So I'm just writing in architecture. So the MLE of architecture is this 0 by 24. Okay. Okay, so just hold on. There is an issue in the recording. So let me see how to fix it. Let's ignore it. Okay, so the first part is, I hope, clear. Now let's move to the next part. Okay, so now let's move to the next part. So next part is you need to guess the GT estimate. So what is GT? It's a good Turing estimate of the word architecture. Now what is this good Turing estimate, if you recall? So what is this good Turing estimate, if you recall correctly? So to just to recap, maybe I'm going to the next slide. Just to recap. So what is the good Turing estimate? So what is the good Turing estimate? So what good Turing says? So in your corpus, so suppose this is your corpus. So this is your corpus. This is just for recall. I hope you know already, but for the sake of completion, I'm just. So this is your corpus. In this corpus, there are multiple words. So there are multiple words. Now thing is that, So some of the words has occurred just once. So this is the frequency of each of these words. So some of the words occurred just once, some of the occurs word twice, some of the occurs word thrice, and it goes on. Okay. Some of the words occurred in time. Okay. Now, so for these words, so the words which has like non-zero frequency count, it's easy to guess their MLE and all this. But suppose if a word has not occurred in your corpus, then how will you guess their frequency? Like how will you guess their probability? So how will you get their probability and all this? It's not possible because you have not seen those words in your vocab. So in your corpus previously, so it's not possible to just go by this count based probability rule because you have not seen those things. So the numerator will be always 0. So it's not possible to get the MLE for those words. So what is the way around? So for this thing, so this good Turing estimate says, okay, so there is nothing to worry. We can always guess their probability or count, whatever you can say, by the next occurred word. Right? Basically, suppose, so let's denote this thing. So maybe there are words, there can be multiple words. So W1 multiple words with occurred once. There will be words which occurs twice and all these things. So let's denote their count by n1. Okay. So n1 basically number of words which occurred once. Okay. Similarly, you can define n2, the number of words which occurred twice, in n3, and such. Now, what this estimate says? So, to guess the count of the words that occurred. Okay, so that occurred C time. So in C time, okay, we will take help from the words which occurred C plus 1 time. So basically, to guess this thing, we will take help from C3. To guess this thing, we will take help from A. Okay. So let's see. So suppose, so what is the formula then? The formula is pretty simple. So now suppose we will guess. So let's see. Let's guess the GT for words with count C. Okay. So suppose this is the original count. Now after GT, let's see, the original count C will be C star. Okay, so just denote this. So then how will you guess this thing? So basically what is this thing? So basically what we will do, we will just take the help from the C plus 1 occurred word. So how will you? So there are how many words are there with occurrence of C plus 1? Okay. So there are n. So according to this formula, there are n C plus 1 words which has occurrence of C plus 1. So total number of word then C plus 1 into. So this is the total count. So there are n C plus 1 number of words and each occurs C plus 1 time. So this is the total. Now we are dividing this count by the word which occurred in C time. So now this is the Now this is the effective count of this C after GT estimate. This is the formula. Now in our suppose now we want to guess what is the GT estimate for C equal to 0. So basically the word that has not previously seen in the corpus. So how will you guess that? Then C star for this will be, if you just replace C0, then it will be N1, then N1 into 1 will be N1, and then N0. So basically it will be N1 by N0. Now this is the thing. So this is the formula. But how will you know if the word is not occurred in your corpus previously? So how will you know the N0? So what does this N0 suggest? So according to this formula is the number of words which occurred 0 times. But if the word has not occurred previously, so how will you get this count? So for that, if you see in the lecture, so there is an assumption for N0 we can replace it with N. Okay, so the total number of diagram or diagram, whatever the thing you are considering. So this is the formula. Okay, so N1 by N. Okay, so now let's see what will be the answer for this thing. So let's see what will be the answer for this thing. So architecture, like there are 0 occurrence for architecture. So to guess this thing, we will need to get the words which occurred once. So basically we need N1. Okay. Now what is N1 here? So what is N1 here? So what is N1 here? So it is 4, because like you can see, so there are 4 words which occurred once. So N1 is 4. So N1 is 4. Now how will you get the estimate of GT estimate of architecture? So it will be, so what is the formula? N1 by N. So here N1 is 4. And what is N? N we have seen previously, it is 29. The total number of words in your formula. So it is 29. So this is the answer. Okay. So the first answer is 0 by 25 and the second answer is 4 by 25. Yeah. So this is, if you see this thing. So I've just elaborated, but you can see. Okay. So let's see what happened here. Okay. So yeah, so I hope you get the point. So let's move the next question. Okay. So this question is also related to smoothing technique. So here what they are asking is that, like you need to use the linear interpolation to estimate PWN given WN minus 1. So what kind of probability is this, if you can guess? So this is a diagram probability, because in diagram, to guess the probability of a word, you need to check the previous 2 words. So here you can see. So to guess the probability of the nth word, you are saying n minus 1 and n minus 2th word. So this is a diagram probability. Now what is the WN here? So they are asking, okay, you need to get the WN for all the things. So A, B, C, D. So you will get 5 probabilities. You can see in the answer also there are 5 probabilities. And what is n minus 1 and n minus 2 here? It is A and C. Okay, it is A and C. And they are saying another thing. So weights of the biogram and unigram models are 0.2 and 0.1. Okay, so the question is there. But before going to the question, again let's recap what is linear interpolation estimate. Okay, so let's go to the slide. Let's go to let's clear it. Okay, let's clear it. So what is the continuation probability? Okay, so linear interpolation here in the linear interpolation. So let's see, let's write linear interpolation, maybe linear interpolation LIP. Okay, so just short, a linear interpolation of WN given WN minus 1 W minus 2. Okay, basically I should write it differently. It is It is basically wn minus 2. Then okay, so the thing is pretty simple. So as the name suggests, it's a linear combination. So linear interpolation. So linear combination of different n-gram probabilities. So basically this is a diagram. So basically this is a diagram. So let's see, it will be a interpolation of actual diagram probability plus bigram probability. So what will be the bigram probability? So to guess this nth word, you just need to see the previous word. Okay, so you just need to see the previous word. This is the bigram probability, and next is the unigram. Okay, so this is the unigram. So unigram, for unigram probability, you don't need to see any of the previous thing. You just predict from that word only. So this is a count based approach. Okay, so this is the diagram. This is the bigram. This is the bigram, and this is the unigram. So there are three probability distributions. So one from diagram probability, one for bigram probability, one for unigram. To guess this thing. Okay. Now they are saying this is linear interpolation. So there should be some like coefficient before adding those things. So basically, suppose this is lambda 1, this is lambda 2, this is lambda 3. So they are summing three different n-gram probabilities with some linear coefficient. Okay. Now what is the constant then? So this lambda 1 plus lambda 2 plus lambda 3 should be equal to 1. So basically in general, so if there are n such lambdas, so then lambda I should be, summation of this lambda I should be. So as it is a diagram probability, so we start with diagram and end with unigram. So and we have just 3 lambdas. But if you go with higher order grams, so then we will have multiple such lambdas. But only constant is that those lambdas, summation of those lambdas will be 1. Okay, so this is just a recap. Now let's see what they are asking. Okay, so now they are asking. So okay, let's write in the next slide. Okay. Now they are asking probability of A, B, C, and D. So differently, and the this is C and A, given C and A. Okay. So they are given CA. They are asking for different things. So it can be A. So they are asking for B, C equal to A, P, B equal to CA, P, C equal given CA, P, B given CA, B given CA. So there are 5 probabilities they want to do. But let's for simplicity just ignore those things. You can do it by yourself. Now let's see. Here I will solve this, the first one. Okay. So as per the formula, how will you solve this thing? So this is a diagram thing. So first the actual diagram probability. Okay. Then the bigram probability. And then the unigram probability. This is the thing. And it should be accompanied with some factors, linear factors. Okay. Now let's see what are different things that are already given in the question. So let's start with the probability. This thing. Okay. So I'm just writing it here. E A given C. So how to calculate this probability? You just need the count of CA and count of CA. Okay. So the count of CAA and the count of CA. Let's check in the table. Okay, so the count of CA is 0. Okay. So the count of CA is 0. So we don't need to see the denominator because it is already 0 there. Okay. So let's write it here. So it will be lambda 1 into 0. Now let's go to the next part. PA given A. So PA given A. How to calculate this thing? It will be count of AA, count of A. Let's see what is the count of A in the table. You can see the count of A is 0 also. So there is no need to go further. So it will be the probability of this thing will be also 0. Okay. So it will be lambda 2 into 0. Now let's see what is the probability of EA. What is the probability of EA? How to calculate this thing? The count of A by total count of all this, total count of all. So basically we are going with unigram, so we will need to find the total different unigrams. Okay. Total unigram. Now see, the count of A is 10, and what is the total number of different unigrams? So you just need to sum up over this column. So it will be, if you calculate, so it will be 16 for 4, 20, 18 plus 12, 20, 20, 20, 40, it is 50. So total, so it will be 10 by 50. It will be 1 by 5. Okay. So it will be lambda 3 into 1 by. Now these things are 0 already, so we should not calculate. So basically we are stuck here. So it is lambda 3 into 1 by. Now what is lambda 3? Basically it's a coefficient for unigram. So unigram coefficient. So let's see in the question. So in the question it is saying that, so the unigram weights is 0.1. So it is given, it is 0.1. So actually I am writing it as a coefficient. In the question it is at weights. Okay. So it's lambda 3 is 0.1. So 0.1 into 1. So what will be the things in? What is this? 0.1 into 0. What is this? 2. Now if you sum 0.0. So this is the first answer. Okay, let's see. Yeah, you can see they have done this thing. Okay. Now, I guess in the similar way you can find the other probabilities also. You can find the probability of other probabilities also. But one thing you should notice, like here they are only given the weights of biogram and unigram, which is 0.2 and 0.5. Okay. So in this thing, so lambda 2 and lambda 3 are given. Now how should you get this lambda 1? How will you get this lambda 1? So the thing is simple. As per this, like if you see the previous slide, this summation should be 1. So in general the summation of all lambdas should be 1. So from this thing you can guess the lambda 1. So basically it will be 1 minus lambda 2 minus lambda 3. It will be 0.7. Accordingly you will get the value of all the other probabilities. So I hope it is clear enough. So you can see here they have calculated B by C. So all these things are already calculated. You can check it. So when they give in such type of questions, just write the formula and see what are the different things already given and what are the different things that we need to find. Then these questions are pretty simple. You just put the calculate the value and put into the equation and get the result. So these things are pretty clear. Okay, so this is the answer. The actual answer is Okay, let's move on to the next question. Okay. Okay, so what is the question? The question is like that, he use back-off smoothing. Okay, the same question, but they are asking with different smoothing algorithm. So their technique actually is not a technique. So here they are asking about back-off smoothing. So what is back-off smoothing? Just to recall, what is back-off smoothing? If you can recall it, So what is back-off smoothing? So right, let's write it here. Okay, so let's write it here. So P back off, the same thing. So just write the formula as it is. So PW. So this is this. So this diagram thing. So P back off of Wn given Wn minus 2 Wn minus 1. It is basically if basically there is a condition if Wn minus 2 Wn minus 1 Wn is present. So basically this, if this diagram is present, then it will be the same diagram probability, but with a discounted factor. So with a discounted factor, you can see here they already given this thing. So this is the discounting thing. So if the actual probability is px, then the new probability will be original minus 1 by 60. So the original minus 1 by 60. So this is the thing. So if this count is present, so this is, then we need to go with this formula. Else we'll go one step down and we will need to find the backup probability of the bigram thing. So same thing, but with the bigram thing, but there will be a lambda involved. Okay. Lambda of Wn minus 2. Okay. So this is the thing. So I hope I have written it correctly. Yeah. So this is the first part. So if this diagram present, then we will go with the simple diagram probability, but with a discounted factor. But if this diagram is not present, then we will go for bigram thing and with a lambda. Similarly, if we don't find this bigram thing, then we again need to go for a next level. So we need to go for backup of unigram. But the formula is like this. This is the back-off smoothing. Now let's go to the actual question. Okay, so the same question is there. You need to guess the probability of P, A, B, C, D, E, all this thing, and given CA. So given CA, we need to give the probability. Let's do one by one. It's not possible to do all the, like for all this is A, B, C, D, and D. So let's start for A only and see how to solve this thing. Okay. So what they are asking P back off of first one. Okay, so first one given CA. Is it? Yeah. So it is CA, and we are going with the first one. Now, as per the formula, what? Okay. So now see. So if they are asking such a question, so what you need to do is that you need to check. Okay. So what are the formulas? What are the formulas that I need to follow? Okay. So this is the thing. So let's check. Okay, if the diagram is present or not. If CAA as per this thing is present or not. Is present. Let's check. Is present or not in the table. Yeah. So this CA is not present. Okay. So we are out of luck. So we should not go with the first. We cannot go. So we cannot go with the first part. So we need to back. Like go to the next level. So we need to go for the next part because CA is not present. So the count of CO is 0. So we will not go for the first one. So we will go for the next one. So then what will be the thing? So it will be lambda of CA into probability backup. This is A. Okay. Now similarly we need to find this thing. How will you find this thing? How will you found this thing? Okay, so let's start with this one. So probability of back of A. First check, okay, if A present or not. A is present. Let's see in the table if A is present or not. A's count is 0. So again we are out of luck. Okay, so it is 0. So we should not go with the first part. So we will need to backtrack the next. So the next problem for the diagram. So it is already in the diagram thing. So we need to go for the unigram. So it will be lambda A probability back of A. Okay, probability of back of. Now again we have these unknowns. We don't know lambda A and this, but let's see the probability of back of. Okay, see, let's see according so if A is present or not. If A is present in the chart, let's see A is present or not. Yeah, A is present and it is 10. Okay, its count is 10. So it's present. So it's present. But the thing is that so then we need to go for the discount. So we need to we can go with the first part, but with the discounting. So it will be discounted of A. Then what is the value for this one? So probability of PA. So basically this is probability of PA minus 1 by 16. Now how will you get this probability of PA? How will you get this probability of PA? So it's easy. Basically it will be 10 by 50 as per this table. So A occurred 10 times and total number of unigram is 50. If you sum up this count column of unigram, you will get 50. So it is 10 by 50. And if you minus this thing, you will get the PB of B. Okay. PB of B. Okay, then you can plug it the value here. But still you have to find this lambdas. How will you find these lambdas? So if you remember, this lambdas are summation. So how will you find this lambda? Basically you can write it here only. So you can write it here only if you want. So basically how will you find this thing? How will you find this thing? Lambdas. Okay, so let's write it here. So we are total number. So we are finding the probability of PA given CA, PB given CA, PC given CA, PD given CA, and PE given CA. Here this is E. And what is the summation of all these things? So all the probabilities, it will be 1. It will be 1 because there are no other ways you can go according to this n1. So you only can have this much of different characters only, A, B, C, D. So using this formula, you can find the lambda of CA. Because for this thing you will find some lambdas. So suppose this is some. So what is the P of CA? So P of CA is what is the what is this thing? So it will be P of lambda CA. So it will be lambda CA into lambda A. Basically this is PB also. If you just replace this thing, so it will be lambda into PBO. PBO is this thing. So 120 into 1 by 16. Just if you do this sum, it will be, sorry, it will be 10 by 15 minus 1 by 16. Like this way, you will find this thing also. You will find this thing also. This thing, this thing. So you will find this thing. So let's see. So B, C, and E. So this B, C, and E, you can find it directly because you have the count for this diagram. Okay, so you have the count for this diagram. So you will find the find from this formula only. So there will be no lambda involved. So you will just find the formula from this the first part only because the n-gram is present. Okay, but for D and A, there will be some this kind of lambda C or something. So, and the next step, similarly for how will you find this lambda A? So you will be multiple problems. So okay, how will you find this lambda A? So you also have this P A given A plus P B given A dot plus P E given A. It will be 1. So from this formula, you will find the value of lambda. Okay, you will find the value of lambda, and you can plug it here and find all these properties. Okay, so this thing is pretty big, so I am not want to go through each of the steps, but I hope the concept is clear. So yeah, so let's see. This is the thing. So for the first part is CA, and suppose same thing. So CA lambda CA will just go for the diagram thing and same thing. And lambda A given A, you will find this thing. So you just put it here. Similarly, you can find the probability of B given CA. So you already, because like for as I have said earlier, so for P given CA, you don't need to find anything, any lambda, because P, so CAB is already present. So but here only catch is that you need to discount it. So just 3 by 8, and you will just discount it by 1 by 16. So you will get the probability. Similarly, B given A, this diagram thing also you can find because AB is there, but you just need to discount it. So similarly, you will find CA given C, then C given C, similar D and E, and then you just use this summation formula of 1 to get the lambda value, and you will get this lambda, and then use this formula to find the lambda C, and ultimately you know lambda C and lambda, and you can put all the thing to the individual formulas to get the ultimate value for each of these things. So this is the ultimate. So I hope this is kind of clear. I hope. If not, just go through the example. I hope it's clear. So the thing is that only thing you need to remember. So this is the backup formula. This is the backup formula. So this is the backup formula for diagram. There will be backup formula for bigram, unigram, or maybe for n-gram. So there will be. So what is the formula for diagram? So if the diagram present, then you will go with this discounted diagram probability. If the diagram is not present, you will go one step down and go for backup of bigram probability, but with like you need to multiply with a lambda thing. So this is the lambda. So this is the thing. So for each of these questions, the questions are like from the question. If you just look the question, you might feel like okay, so the question is very big, it's very difficult. But no, if you just write the formula, and see what are the parts that I need to calculate, and check what are the values that are already available and what are the values I need to derive, then this thing is pretty clear. Just see, okay, so this thing is already done, then we need to calculate this lambda c and all this thing. Then this part is very simple. But just one thing, just read the question carefully, see what type of smoothing they are asking, remember the formula, write what are the different parts that are already given in the question, and what are the things that I need to calculate, and then you are good to go with the problem. Okay, so I hope this is clear. So let's go for the next question. Okay. So next question is again similar to this another smoothing algorithm. It's a Ness smoothing thing. So again, so before going to the question, let's go to the formula of Ness. Just recap. Okay, just recap the formula of Ness. So it's kind of the formula is kind of big, but if you can, this is the only thing. So if you remember the formula, there is nothing in the problem. So you can just put the value and get the answer. Okay. So basically, Nissan also. So what is this thing given? Okay. So it is Wn given Wn minus 1. Basically, it is if I write it correctly, it will be max of count Wn minus 1 Wn. So basically you should not write this Wn. So this is just a diagram thing. Count of Wn. We need to discount it by d. Okay. We need to discount it by d. 0 is here. So just to think that this denominator, like this numerator, should not go below 0. So this is just to say for this sake only. And denominator is count of W minus. Okay, so there is another thing. So another part of this thing. So it will be plus lambda of Wn minus 1. Okay. And continuation probability of. So this is the continuation probability. So I'll just write it. So this is the continuation probability. Already, if you remember, already discussed this. What is the continuation probability of a word? Just if you forget, just go back and check the formula. Okay. Now see. What the okay. So and also, so you can find this thing directly. This lambda a minus 1. You can find this directly. The formula is d given count of Wn minus 1 and number of different words for which the count of Wn minus 1 comma W greater than 0. Okay. So basically number of unique diagram that has this W minus 1. Now let's see what are the different thing you need to calculate. For our case, what should be the formula? It should be what they are asking. They are asking B given A. Okay, so they are asking if you just put it here, you will get the formula. You will get the things that they want to know. Okay. So basically it will be, okay, just maybe this space is not very nice. So max of count AB minus D is given. I think D is 0. Let's see what is given. 0.75. Okay, so D is given as 0.75 comma 0 by count of A plus lambda A continuation probability of B. So this is the thing we need to calculate. Now see, We already know this thing. We already know this thing. Okay, so we know count of AB. We know count of AB from the table. So the table is given. We know count of AB. We also know count of A. So this thing already known. So what are the unknowns here? Unknown is lambda A and continuation probability of B. But both things can be calculated. So lambda A can be calculated using this formula only. So what is the thing? So what is the lambda A then? Lambda will be D matlab 0.75 by count of this thing. So count of n minus 1. So count of the last one. So it will be count of A, okay, into, so number of bigram where A present. Okay, so A present as the first character. So let's see what are the different characters where A present as the first character. So it will be 1, 2, 3. Okay, so this 4 is A, B, A, C and E. So it is 3. So it will be 3. Okay, so you get this lambda, and also you can find the counter also you can find this one. And how will you get the continuation probability? If you remember the continuation probability formula, I think I have written this in the last slide. Yeah, this is the one. So here total number of, so we are just the total number of unique diagram in the corpus and total number of unique diagram with the W ends with. So what is this probability of W? It will be total number of bigram, and total number of bigram that ends with B. Okay, so the bigram that ends with B and total number of bigrams. So what are the total number of bigrams? So total number of bigrams is AB, AC, AE. Okay, so there are 3 and another CA. CA is also a bigram because CA is also there. So with non-zero count. So there are 4 different bigrams. So it is 4. So it is 4. And what are the, like, how many bigram with ends with B? Let's check. So it will be 1. Okay, so it's just 1. AB. Okay. So it is 1. Okay. Now you have all the value. You know the lambda A. You know count B. You just put the value here and you will find the value of this next. Okay, so the main point is that these questions, maybe if you see in the surface level, these questions look big and maybe difficult. But if you write the formula, if you go for individual component, and you need to see, okay, so what are the components that I already know, and or I can do the math to get the value for those components, and then you just put this value to the actual formula and you get the value. So here's the thing, just keep cool, and find the formula. Okay, so find the different components for which the values are already given and the parts for which I need to calculate the, and then you are good to go. Okay, so let's see. So here this is the thing. You already, let's see. Okay, so similarly you can find this thing. So continuation probability is there, lambda is there, and then you just put this value to the actual formula. Okay, now let's go to the next question, which is related to the Markov model. Okay, so again recall, so what is the Markov model? If you remember, what is Markov model? What is Markov model? What is? So basically this is the thing. So suppose these are the different states. Okay, this is the state I minus 3, state I minus 2, state I minus 1. There will be multiple steps after the I minus 1. There will be other state before this I minus 3. Now what this Markov says that this state is depending upon all the previous state. This Si depends upon all the previous states. Okay, so this is the thing. So this is the simple Markov model. Now the assumption. So what is the first order Markov? So the first order Markov is Si. It only depends upon S I minus 1. This is the first. So this is the, if Si only depends upon this is the first order. Similarly, if Si depends upon the last two state, this is the second order Markov model. Okay. So here Si depends upon Si minus 2. Similarly, if it depends upon the last three state, it will be the third order Markov model. Okay. This is the third order Markov model. And such you can go on. So you can keep increasing the order. So it will depend upon the more and more previous states. So this is the simple thing. And you can see there is a similarity between this Markov model and N-gram language model. So N-gram language model you can see. So in the what is the N-gram language model? In the N-gram language model, nth word depends upon last n minus 1 word. Similarly here this the word is like a states. Okay. Okay. Now let's go to the question. So here they are saying, okay, this is they are saying, so this is a first order Markov model. So they already said, okay, so you don't need to go much beyond. So this is a first order Markov model. So a state only depends upon the last state. So a state only depends upon the last state. So if we are in today, so we just need to see what is the yesterday. So basically this is the thing. Now see. Now what is this thing? So this is kind of a transition probability. So if you are in a rainy day, so what is the probability that next day is foggy? Okay. What is the probability that next day will be sunny? Okay, and what is the probability that next day again will be rainy? So if you see from this thing, so if today is rainy, then tomorrow will also be rainy with a probability of 0.6. Tomorrow will be foggy with a probability of 0.2. Similarly, tomorrow will be sunny with a probability of 0.2. And you can see all this outgoing probability from this. If you sum those edge weights, it will be 1. A simple probability. So from today, you can go multiple ways, but the total weights of all these edges, the probability should be 1. So you can see the 0.6, 0.2, 0.2. This thing will be 1. Similarly, you can find for other nodes also. Now, what are these things? So they are saying, so assume that yesterday and today are both foggy. Okay, so they are saying, so yesterday was also foggy and today is also foggy. Now, the question is that find the probability that tomorrow will be sunny. Okay, so this question is very simple. So you don't need to do anything. So basically they are asking what is the probability of tomorrow will be sunny. Okay, but what we know is that today is foggy. So we know today. So we are here. So we know today is foggy. So if we know today is foggy, then so what is the probability tomorrow will be sunny? 0.2. So it will be 0.2. So the answer will be 0.2. But I guess this question is wrong. So there is a larger part. So the actual question is this. So that if nothing is given, the actual answer is 0.2. Okay. So because today is foggy, tomorrow will be sunny with the probability of 0.2. Because like this is a first order Markov model, so to guess the probability of tomorrow, we just need to consider the today only. So we should not go yesterday because this is the first order Markov model. Now see the actual question. So actual question is that find the probability for the Sunday day after tomorrow. Okay, so now they are saying, okay, so what they have given to us. So they said, okay, so yesterday and today both are foggy. Let us know what is the probability that day after tomorrow will be sunny. Okay. Day after tomorrow will be sunny. So this is a simple probability question. So if just need to go step by step. Okay. So they are asking. Okay. So this is a first order Markov model. This is a first order Markov model. So let's go to the next slide. What we know? We know about yesterday. We know about today. We don't know about tomorrow. And they are asking about day after tomorrow. So what do you know? Today is foggy. Yesterday is foggy. Today is also foggy. And they are asking for find the probability of day after tomorrow will be sunny. So they are asking for that day after tomorrow will be sunny. So day after tomorrow will be sunny. So they are asking for this point only. Okay. So to go to this thing, so to go to this point, we need to calculate this thing. So to calculate tomorrow, as it is as per the question, it is the first order Markov model, so you only need to consider the today only. So this yesterday part is not necessary for us. It's irrelevant for us. So let's see. So now what is the question? Now question is today is foggy or is the probability is the day after tomorrow is. So what are the different possibilities? Tomorrow can be foggy. Tomorrow can be sunny. Tomorrow can be rainy. Okay. So today is foggy, we know, but tomorrow can be again foggy. Tomorrow can be sunny. Tomorrow can be rainy. And from tomorrow, and we also know that the day after tomorrow should be sunny. So they are just asking, so we just need to calculate the probability of sunny. So this is only one possibility. So from tomorrow, this is single path. This is single path. So this is the multiple way we can find the probability. So one way is this. So today is foggy, tomorrow is foggy, but the day after tomorrow is sunny. Again, today is foggy, tomorrow is sunny, day after tomorrow is sunny. Again, today is foggy, tomorrow is rainy, and day after tomorrow. So there are three parts. So we just need to sum the three probabilities. So we need to find the probability of Fs plus probability of Fss plus probability of FRS. This is the total probability. So now how to calculate this thing? How to calculate this thing? So we already know today's this thing. So today is foggy. Yeah, today is foggy. Okay. But what is the transition probability from? So we need to calculate this thing and we need to calculate this thing. And if you calculate this thing, you will get the. So the thing is pretty simple. So let's find this one only. So if just find the first part. So this one. So today is foggy, we already know. But what is the probability that tomorrow will be foggy given today is foggy? Into day after tomorrow will be sunny given tomorrow will be foggy. This is the thing. You're getting that? So this is for tomorrow. This is today. This is day after tomorrow. This is so given today is foggy. So basically you already know today is foggy. So the probability is 1. So there is no need to put it here. So this is for today. So we already know this is 1 because the question they are saying so today is foggy. So this is no need. There is no need to put it here. But suppose this is here. Okay. So the total probability is that today is foggy. Given today is foggy, what is the probability is tomorrow is foggy? Given tomorrow is foggy, what is the probability is day after tomorrow is? So just chain reaction. Similarly, you will found this thing, you will found this thing, and then add those probabilities. So now, and how will you get this probabilities? This you will find this thing from transitional probability. See, if today is foggy, tomorrow what will be the probabilities tomorrow will be also foggy. So just see the table. So if today is foggy, what is the probabilities tomorrow is also foggy? It's 0.5. Okay, it is 0.5. So you just enter those things. So it will be. So just calculate this thing. It will be 1 because this the probability of f is, but like today is foggy is already we know it's 1, and 0.5 into what is the probability? Today is foggy whereas tomorrow is sunny. You can see the chart. Today is foggy, tomorrow is sunny. It is 0.2. It is 0.2. So it is 0.2. So what is the probability? 0.01. I'm correct. Okay, just hold on. Just hold on. Okay, and similarly you will find the probability for this thing and this thing only. I hope. Okay, sorry. So this is 0.10. So probability 10 will be 0.1. Okay. Similarly, you will find the probability for this one and this one, and we will add those. Okay, same thing they have done, but written it here. So 3 different paths they are adding. If you add all these things, you will get the answer. Okay. All these things, you will add the answer. So I hope you can do this. This is easy. Okay, so I have some time. So okay, so let's go to the next question. So what is the question? So question is again the same question. So consider first order Markov model. So they are saying, so consider first order as like the previous question. Now find the probability of the sequence of being happy and grumpy on day 1 and day 2. Okay. So they are saying, okay, so day 1, day 2 initial probabilities. So the question is slightly different. So they are now asking, so what is the probability that today you will be happy and tomorrow you will be grumpy? Okay. Now you can say, okay, how this happy and grumpy come into picture? So previously we are only working with the weather. Now how this happy and grumpy? So for this thing only they also provided a table. So given a day is sunny, what is the probability is that you will be happy that day or you will be grumpy that day. Similarly, if the weather is foggy, so what is the probability that you will be happy that day, grumpy that day? So same thing with the day. So from that thing you can calculate those. But so, and also the initial probabilities are given. So initially thing is that they are saying, so initially the day can be sunny with 0.5%. So basically the day 1 can be sunny with the 0.5%. It can be foggy with 0.3%, and it can be rainy with a 0.2%. Now how will you calculate the whole thing? Okay, so how will you calculate the whole thing? Okay. Okay. Okay, so let's go to the next one. Okay. So it is day 1 and there is day 2, and what they are asking is that the day 1 you will be happy and day 2 you will be grumpy. The day 1 will be happy and day 2 will be grumpy. Fine. This is the thing they want to know. So what is the probability that in the day 1 you will be happy, day 2 will be grumpy. Now the thing is that now this happy thing will depends upon the day type. So it can be a sunny day, it can be a rainy day, it can be a foggy day. Same. Similarly, this grumpy part also depends upon the day. It depends upon the sunny day. It depends upon the rainy day. It depends upon the foggy day. Okay. Same here. That part clear? Now the thing is that how will you connect those two? So you know this part, you know this part, you know this part. So you know, so if today is sunny, so what is the probability that today will be grumpy? So you know this separately. But how will you connect? The only connection is that. So what is the transition probability from day type? So if today is sunny, what is the probability is tomorrow? So if today is sunny, so this can be like this. This is the thing. Yeah, you are getting the point. So today is sunny and you are happy. Suppose tomorrow can be sunny, tomorrow will be grumpy, tomorrow will be rainy and you will be grumpy, tomorrow will be foggy. So there are multiple routes possible. Okay. So how many possible ways to get there? How many possible ways to get there? If you see, there are multiple possibilities. Okay, so there are multiple possibilities. You can take this route, you can take this route, you can take this route. Similarly, you can take this route, you can take this route, and you can take this route. So how do you do it in a formal way? So you get the overview, like how to calculate it, how to calculate pictorially, how you get the point. So you know this today is happy, so tomorrow I should be grumpy, but is this happy and grumpy depends upon the weather type. Okay, but how you connect those things, you know. Now just you need to get the probabilities for different things. Let's see how to do it. So thing is pretty simple. I hope some of you already know how to do it. Okay, so yeah. Okay, let's see. So the first part is that what they are saying. Okay, so if today is sunny, what is the probability is that tomorrow will be today I will be happy. So this is the first part. So this is the first box they are calculating. This is the first box they are calculating. If today is sunny, what is the probability is I am happy. Okay. If today is sunny, given today is sunny, what is the probability I am happy? This is the total probability. Okay, so this is today is sunny, tomorrow is if today is sunny, what is the probability is today I will be happy. So the thing is simple. Today is sunny and the given sunny, what is the probability is I am happy. So the initial probability is given. So the sunny is 0.5 and given sunny I am happy will be 0.7. So it will be 0. So similarly you will find all these things. So given sunny, foggy and rainy, you will find the different thing. Now you need to just go beyond the first thing. So you need to go here. So for this thing you need to calculate the probability, the transition probability from day type to day type. So given today is sunny, I am happy, what is the probability is that tomorrow will be sunny. So this happy thing is not depends upon the day, but the probability depends upon this thing. So if today is sunny, what is the probability is tomorrow will be sunny. So these things are already present in the so you need to calculate those things. So now see this thing. Okay, so what they are calculating is that they are calculating what they are calculating. If you can guess, they are calculating this part. They are calculating this path. Okay, so they are calculating this. they are calculating this part. So just see. So day 2 I will be grumpy, given so they are already assuming, so given the day 2 will be sunny, and day 1 and emotion 1. So for now they are calculating the box 2. Now they are calculating the box 2. Now this box depends upon three things. So I can come from this sunny part, I can come from this rainy part, or I can come from this foggy part. But this sunny part is also depends upon the first box. Okay. Similarly, for if we go for this way, if I go from this way, then I need to calculate the same part. So this part is common. But this transition property is different for each of these things. Okay. So this is the first. This thing is the first block. You can see. Just they are summing all this thing, and they will get that. Similarly, this is the second part. So I am grumpy, day 2 is foggy. So they are calculating this part. Okay. And similarly, the next they will be calculating the middle part, and they will sum this up. Yeah. So see, and they will sum this up and get the final answer. Okay. The question is the question may look difficult, but if you just draw it and see what is the different connection between different transitions from one day to other day, this thing is pretty very simple. You just have the drawing in your head. So not in your head, actually you can write it in your copy also. So from one day to other day, so what are the different paths I can go from one state to other states. So I need to, if the paths are parallel, then I need to sum the probabilities. If the paths are sequential, then I need to multiply the probabilities. So these things. So I hope this is kind of clear. Okay, so the last question is that similar. So you feel grumpy on day 1, you feel happy on day 2, you feel happy on day 3. What is the probability? All they are sunny. So what is the probability of all they are sunny? So now what is the grumpy, happy, and okay. Now, so this is day 1, this is day 2, this is day 3. Okay, so day 1 I am happy, no, grumpy, day 2 is happy, day 3 is okay. So this is the thing. So day 1 I am grumpy, day 2 I am happy, and day 3 I am also happy. So this thing is given. Now they are asking, so what is the probability that all these they are sunny? So this is the emotion. So this is the emotion. Weather. So all will be sunny. This is the thing. So what is the probability that all these beings? Now how will you do that? How will you calculate this thing? If you think, just think it, like how to calculate this thing. From previous example, if you just think of how to do this thing. So basically, so day 1 will be sunny, day 2 will be sunny, day 3 will be also sunny. Okay, now given key the day 1 I am grumpy, day 2 I am happy, day 3 I am happy. Okay, let's do it. If you don't think. So what is the thing? If I write it uh, in probability form, so can you guess this is a only one way you can go with this thing, huh? Because the transition is from weather to weather. Okay, so there are not multiple paths, so you can go from weather to weather. So there is only one path. So this thing, and this thing. So the first thing is that the first thing you should calculate ki today the probability of, so let's write it day 1. So suppose, so probability of day 1. So I'm writing it here only. Okay, so the probability of day 1 so is sunny. Okay, now given today is sunny, what is the probability of gram? This is the first part. Okay, so sunny and grumpy. So this is sunny and grumpy. So today is sunny, and given sunny, what is the probability today is grumpy? Second thing, what is the second thing? Similar thing. The probability of sunny today, like day 2 is sunny, but what is depends upon the previous. This is a first order Markov, so it depends upon the day 1. So given today is sunny, what like so today is sunny. So given previous day is sunny, what is the probability is today is sunny? And today is sunny, we know what is the probability that I am happy. Similarly, day 3 is sunny, but given day 2 is also sunny. So day 2 is also sunny. So what is the probability that day 2 is sunny? And okay, so this 3 conditions should occur simultaneously. So this is not a parallel path. So this is sequential. So we need to multiply the probabilities. Okay, so we need to multiply this probabilities, and we will get the answer. So I hope you understand the thing. So they are saying ki day 1 is you are grumpy, day 2 you are happy, day 3 you are happy. Now they are asking, so what is the probability ki they both the like all the days are sunny? So how can you get the thing? So I can get the thing. So one possible way is that like the day 1 is sunny, the probability of day 1 is sunny. Okay, so the probability of day 1 is sunny, and if the day 1 is sunny, what is the probability that that day is grumpy? So from the second day onwards, what do you need to calculate? Ki, like day 2 is sunny, but given the previous day is sunny. So it depends upon the previous day. There is a probability involved. So so what is the probability? Ki today is sunny, tomorrow also be sunny. So this is this. And given today is sunny, so what is the probability I'm happy? Similarly, this thing. So if you calculate all this probability and multiply, you will get the answer. So this is the thing. In the question they are writing it here plus, so this is wrong. So this thing is correct. So this row is correct. Okay. So this is the answer. Okay. So that's all for this week. I hope you already get the idea. So how to calculate the probabilities, how to go with the different kind of smoothing problems. The main for if you see the thing, so there are multiple, like I think there are 4 or 5 smoothing techniques. But the thing is that these smoothing techniques are very simple, but the formula looks difficult. For the examination purpose, so if they So suppose in the exam they will give you some kind of this kind of smoothing problem, with some ask to solve by maybe this back of smoothing or something else. What do you need to do? Just just think. Okay, so there are 4 or 5 such smoothing algorithms. So write it down. So before exam, just write it down in a maybe cheat. So just remember all these things. Okay, so just remember all the different formulas. If you know the formula, then the problems are pretty simple. You just need to see. Okay, so if you remember the formula. Okay, you remember the formula. Then just see. Okay, in the formula, which components are already present in the question. So what are the different values are already present in the question. So you don't need to bother about them. And the next part is that the value for, like, you need to calculate. If just then you go step by step. So if in the exam, if they provide the formula, then you don't need to memorize the formula also. But suppose I am guessing they will not give you the formula, so then just you need to remember the formula. And for the probability, this Markov thing, if you just, so this is just common sense. This probability thing is just a common sense. You just have this common sense, you will solve this probability. So this probability questions are very simple. If you just think step by step. Okay, so this today is this day, so tomorrow is this. What is the probability? So how I can go from today to tomorrow? So what are the different parts I can go from today to tomorrow? If you just think like step by step, these probabilities are pretty simple, and most of the time they will like ask for this faster Markov model only. Okay, so you don't need to calculate like bigger second order probability thing or something. It's just the first order thing. So just you need to look back the previous day or something, the last steps for different things. Yeah. So the main part is that the problems are not difficult. Just see the question carefully. Think of how to solve this thing and go step by step. Don't like memorize. It is just the you need to memorize something. So just memorize the formula. I don't know. Maybe in the exam they will give you the formulas also. But yeah, for safety purpose, just remember those formulas. But having like given the formula, the thing is that you need to understand what are the parts that already are there in the problem, and what are the parts that I need to calculate. Okay. And same for this probability part also. So what the things are given, what the thing they're asking for, and to go that state, what are the like different paths that I can go to the target state. Like maybe they are asking for tn and tn minus 1 is given. So what are the different paths I can go from tn, like what are the different paths to go to tn from tn minus 1. Then just think. Another thing is that if the paths are parallel, then you need to add the probabilities, and if the paths are sequential, then you need to multiply sequential. This is the basic probability thing. Okay. So that's for today. So let's meet next week. Thank you and goodbye. Bye.